Today we are going to start a new chapter, which is nucleus. So in chapter atom we already have learned about nucleus as per Rutherfordic atomic model, as per his experiment, that is alpha ray scattering experiment. He has given some valid point about nucleus. Which are the valid points? One thing, the charge of the nucleus is positive charge and entire mass of the atom is concentrated at nucleus. So I will just give you a quick recap about alpha ray scattering experiment by Rutherford. Okay, so we had nucleus at the center and around that we have electrons revolving, right? So when the alpha ray is coming straight towards the nucleus, we have seen that after collision, or see, after just reaching the distance of closest approach, why it is not undergoing a collision, that is a contact, because alpha ray is having two positive charge. Alpha ray, what is alpha ray? Helium nucleus, so He2 4 it is, and helium nucleus it is, so it don't have any electron. It's not a helium atom, it's a helium nucleus having two proton and two neutron. So this is coming towards the nucleus, and you can understand nucleus is having positive charge and this is having positive charge. So with that kinetic energy it will move, and as it moves towards it, its velocity will decrease because it has to oppose the repulsive force offered by the nucleus on alpha particles. Okay, because both are positive charge. So now it has highest velocity. As it moving towards it, these positive charges are offering repulsive force in this direction. Now it will overcome this repulsive force with the energy it is having. So gradually velocity will come to zero at some point. By that time all the energy would be converted as potential energy and that will come back. Just visualize, just imagine you have a north pole here, a south pole of a magnet in this way. When I am throwing a magnet of this polarity, magnet in this way toward this magnet, what will happen? It will have higher initial velocity. Now see, this north pole would be repelling this north pole. So what it has to do, on going closer towards this north pole, it has to oppose the repulsive, it has to, the opposition or the work done by this magnet to oppose this repulsive force offered by this magnet would be more and more and more, because see, smaller the distance, larger would be the repulsive force. We know in the case of charges it is Coulomb's law, Fc is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. Okay, now it's the same charge. When the distance becomes lesser, the repulsive force would be more. So in short, this will gradually decrease its velocity and comes to a point where velocity becomes zero, and after that point it will return back. So this would be the movement. Okay, anyway, why it has returned back? Because nucleus is positive charge. We know alpha particle is positive charge. Okay, with experiment we know that it is positive charge. Now if nucleus is negative charge, then there won't be a turn back in this way. Okay, in the same direction it has returned its motion. Okay, opposite to the direction of initial velocity, now it has got a velocity in this direction. Okay, anyway, if at all if it is negative charge, this would be attracted, alpha particle would be attracted in this direction and that would go in straight line. As it is, as nucleus is carrying positive charge, it has returned in this way. Now if at all if nucleus is a light particle, what would happen with this high velocity? Let's say this is a bigger particle, it's a smaller particle. So what will happen? This alpha particle can immediately take the smaller nucleus along with it. See, nucleus would be offering repulsive force in this direction, but its mass is higher, right? So it can take the nucleus along with it, but it is not happening in that way, which means that the mass of nucleus is very large, so that this alpha particle has no option other than returning back in the same direction, okay, or in the opposite direction or along the straight line. So this is the initial velocity. In the same line of action it would return back. Okay, now we will conclude all in one sentence, nucleus is the central part of the atom. Okay, and on which almost all the mass and positive charge is concentrated. Why alpha particle is returning back? Because this is offering repulsive force. This is positive, so nucleus also should be positive. Now next thing, why it is returning back? Because its mass is heavier. Mass of the nucleus is heavier. Okay. So these 2 points are very important. All the mass and all the positive charge is concentrated. Almost all the mass, because see, mass of the atom is due to mass of proton and mass of neutron, which is inside nucleus, and also due to mass of electron. So mass of electron, when we are considering mass of electron, I can say it is almost. Okay, if at all I am saying all mass is concentrated, then the problem is, where is this electron? See, we have nucleus and electrons around it. So mass of the atom is size mass of the nucleus plus mass of electron, but mass of electron is very less. I can say mass of the proton is equal to 1087, approximately 1087 times mass of electron. You can verify this. Approximately this is the value. Okay, so mass of proton is very heavier than mass of electron. So this is negligibly small, but still it has mass. So I can say almost the entire mass of an atom is carried by its nucleus. Okay. Next thing is electron move around nucleus, which we already know. Next thing is very important. How can we measure the mass of an atom? Can it be measured in kilogram? No, because see, the nucleus is such a small particle which cannot be measured in kilogram. Okay, if we are measuring in kilogram, we already know what is mass of an electron, 9.1 into 10 power minus 31 kilogram. So always this value would be, kind of complicated value, 10 power minus 31, minus 27, minus 28. So instead of avoiding such scenario, we have defined a new system, a new measurement towards the measuring mass of atomic particle or mass of atom and subatomic particle like neutron, electron and proton, which is nothing but atomic mass unit, AMU. Okay, now onwards we will be taking the measurement of atom, electron, proton in AMUs. Okay, this AMU you can simply convert into SI system, which is in kilogram. Okay, I will explain you the conversion as well. Now, so it's a standard defined, right? See, 1 kilogram is also defined with certain standard, right? It is mass of so and so material kept at so and so, circumstances. This we have already learned in class 11 in physical world. Okay, in second chapter, yes. So similarly, AMU has been defined in a standard which is defined in this way. It is 1/12 of a carbon 12 atom. Now why I have taken carbon? Why can't I take hydrogen? See, carbon is available everywhere and on almost all the surface of material. See, when we are seeing any material, fossil fuel or a fossil or any substance like old, I can say an old wooden pot or mud pot, any substance, whenever we are getting, we will be doing carbon dating, because see, carbon is almost available in, I can say 99% of the material which human is producing, or I can say like with animals it is available, with human being, our body, we have carbon content. So like almost all the materials are having carbon in it, so we have defined with respect to carbon. Okay, so it is 1/12 of a carbon 12 atom. Okay, so carbon is having 6 proton in it, 6 proton, 6 electron and 6 neutron in it. Okay, so carbon, why I am saying carbon 12, we have carbon 13 as well. There are different types. I will explain about what is isotopes. Okay, isotopes are nothing but elements that has got same atomic number and different mass number. So instead of taking other isotopes like C13 or C14, we have to take carbon 12 atom itself. So take one carbon 12 atom and measure its weight in kilogram and divide it with 12. So 1 by 12 of a carbon 12 atom, which is a carbon 12 atom weigh 1.99. So this has experimentally taken. Okay, so carbon 12 atom is measured experimentally and we have divided with 12. So one atom, this is the weight, 1.99 into 10 power minus 26 kilogram. Divide it with 12, then we will get the value. So see, 1 by 12 of a carbon 12 atom is simply weight of a hydrogen atom. Okay, H1. Okay, so both of them are same, but instead of defining it for hydrogen, we are doing it for carbon 12 atom. So one atomic unit or one unit, it can be taken as one AMU or one U. Okay, both are same. One U is equal to 1.6 into 66 into so much into 10 power minus 27 kilogram. Okay, now if I am saying 12 carbon 12 atom means, sorry, 2 carbon 12 atom means it is having a weight of 2 AMU, 2 unit in AMU. Okay, if 3 carbon 12 atom, it is 3 U. If 4 carbon 12 atom, the weight is 4 U. Now if you want to get the weight, the mass in kilogram, what you have to do? This multiplied by 1.66 into 6605 into 10 power minus 27 kilogram. So 1 U is equal to this much kilogram. This is a very, very important thing. Okay, now I think I have mentioned weight instead of mass at certain point in the video. So always take mass. I meant weight for mass. Okay, weight is different and mass is different. Weight is nothing but mass into acceleration due to gravity. So wherever I have mentioned weight, you can watch the video again with considering weight as mass. Okay, wherever I have mentioned, that's wrong thing. So weight is nothing but mass in this explanation, but actually weight is equal to mg. Okay, so here I have done the explanation for mass. The entire video is for calculation of mass of an atom. Okay, thank you.